Hi there, welcome to Gorilla Physics and welcome to Easter Revision Live. Okay, I'm really just doing a bit of an introduction because I want to do a few live streams over this Easter period, and I want to give you a bit of motivation to get yourself started straight away. I think it's really important over this Easter holiday to have your break at the end of the holiday. Okay, that's my main point here. Later on I'm coming back and I'm going to actually do a couple of GCSE papers. I'm going to go through some GCSE exam questions live. So I'm just testing the setup. Can you please let me know that you can hear me loud and clear, that you can see me loud and clear and everything like that during this one. I'm going to do a little bit of a studio tour just for fun, okay, just to show you around what we've got going on and just to test things out, as I said. And I'm also going to talk a couple of bits of physics. I'm going to talk about life cycle of stars, and I'm going to talk about particle physics, because those two parts of physics are really some of the best for me. Like, physics for me is all about getting to know the biggest things, the universe and how that works, and getting to know the smallest things, the particle physics and how that works. So let me know in chat as well if you've got any kind of ideas of things that you want to see. Hi there, somebody's here already, that's great. Let me know if there's things that you want to see over this Easter. Let me know requests. You can also do something, you can also send me really hard questions, ones that you find really quite tricky, to kit@gorillaphysics.com. If you want to actually me to go through a question maybe that you're struggling with, maybe you've found the answers for but you're still not absolutely sure how you're supposed to get there, then by all means you can send me that to my email address, kit@gorillaphysics.com, and you can send me a question that you find really hard and I'll go through that. I'll make a priority of that. If you've got suggestions for things, then send me that as well. Make comments in the main things. If later on, if you're an A-level student and you're thinking, oh, this is going through GCSE papers, then yeah, I understand that. There are some links as well in the description, suggested videos for you guys to actually get on straight away this afternoon whilst I'm not streaming. There's suggestions in the description for that. So I'm going to do a little bit of a tour of my studio, show you around. I will have a little look through the chat just a little bit later on, but I'm going to go back into the webcam. So I'm just getting used to the whole setup here, and I'm going to sort of show you a couple of things around in my studio. This is obviously the desk. That's not the most exciting thing in the world. I'll just take this thing off. This little zone over here is my sort of camera collection zone there. Can you see that? This is one of my sort of favourite toys at the minute. This is a 1980s film camera. This is the Canon A1 and I really enjoy shooting photographs with it. It's proper old-fashioned stuff. I'm quite into photography. You'll see a few things there. Here we've got the visualizer set up as well. We've got the these are the dual screen monitors. These are ASUS sort of 2.5K monitors, and this is the current battleship. You've got to have the RGB these days, haven't you, in your desktop computer? Ignore the mess of wires underneath there. This is a Core i9 with a 1060 Pro graphics card in there as well. Obviously you've got the SSD and you've got the large drive as well. I'm not showing off with that really, but I want to tell you about that because it's a really good deal from a company called Palmcomp. Okay, so check that out in my little Amazon store in the description there as well. And then I want to talk about these two things that we've got on the wall here. This is it's known as the Horsehead Nebula. Okay, it's actually better known as the Pillars of Creation. This is a Hubble Space Telescope image, and this is where we're going to talk about the life cycle of stars, because this is a nebula and this is where stars are born. So I'm going to talk about the life cycle of stars in just a moment. And this, I really love this one as well. This is the smallest things. This is a sort of really high energy particle has collided with a target here, and it's become this kind of shower of subatomic particles. So if you're talking about the atomic model and why you might want to know about that, well, that was some of the key evidence for the atomic model. It really confirmed what Rutherford found in his alpha particle scattering experiment. So that's great, Rachel, thanks a lot. You can hear it fine. Glad to hear that. I actually made a mistake and a little while ago, and I actually streamed privately to myself, and I was, oh no, I did this completely wrong. I thought I was going live, and then I realised, oh, the sound was completely off, and oh, it was a bit embarrassing. But then I looked at the thing, and I was streaming private anyway, so it wasn't a problem in the end. But okay, so we're going to talk through these two things. So this is the visualizer here, and I'm going to talk through the life cycle of stars. I think one thing that people get wrong when they learn the life cycle of stars is they learn all the kind of key points. They learn this turns into this, turns into this, turns into this, but they forget to learn the processes. So I'm just going to add to this diagram the processes that stars go through to get from a nebula to a protostar, for example. The first mark you've got to get in is gravity. Can you see that all right? Probably not with a pencil. Gravity brings the nebula. That nebula is that large cloud of gas and dust that I've just shown you a photo of. Gravity brings it together, and then you get friction and you get high temperatures and pressures. Okay. And these are the conditions for fusion to start. So from a nebula to a protostar, fusion begins. And you've got to say nuclear fusion begins. And then as it heats up, well, you get more and more and more fusion, you get more and more high temperature and pressure, more and more fusion happens. That leads you to a protostar. So those are the little glimmers of light that you can see in those nebulas on my wall. And then from a protostar into the main sequence, where you continuation of fusion, but you also get this kind of balance of forces. And this is what you need to get into this part of your answer, is a balance of two forces. And those forces are gravity inwards and radiation pressure outwards. They really want to read, how come something is in its main sequence? Why is that star this kind of ball shape? It's because of this balance of forces, because of this equilibrium. So you've got to get that into your answer here. You've got to get that into your answer. Now the main sequence, after the main sequence, this is the longest period of a star's life. After the main sequence, there's two options. There's the kind of less mass option or the higher mass option. Now they typically say a sun-like star, a star like our sun. Okay, so something around the mass of our sun. Actually, it's up to about 3 solar masses, but that's extra detail. We don't need a GCSE. Now, at the end of the main sequence, now we're starting to run out of hydrogen to do fusion. The star expands and it cools. So that's the details you need to get from the main sequence to a red giant, expands and cools. And actually they really want you to have the detail that it looks red because it's cooler, and link color to temperature. And actually there's the whole like set of graphs you should remember. Basically, higher temperature stars look bluer, cooler stars look redder in the sky, and don't get confused with redshift with that bit there. So from a red giant into a white dwarf, you get this just kind of drifting off of layers. Okay, so layers, the layers drift into space, and you get left behind a planetary nebula. That's a nebula that's not going to make any new stars. And a white dwarf. And a white dwarf is a small white cooled star. Now eventually fusion will stop completely, and you'll end up with a darker star called a brown dwarf. But the universe, interestingly enough, the universe isn't old enough for us to have any brown dwarfs. So try and think, don't just add these don't just learn these terms of the different stages, learn how it gets from one stage to another, and make sure that you can answer in kind of detail. If it asks you the steps to get from a nebula to the main sequence, you need this kind of level of detail. Now if it has got more mass, so if it's a more massive star, then you go down this route. It's going to expand and cool again, so that's the same. Expands and cools again, but it's going to become a red supergiant, so much larger than a red giant from a sun-like star, and then it's going to explode. Okay, so this is the layers actually collapsing on each other, and you get this colossal explosion called a supernova. And it's in that supernova that really heavy elements are made. And from that you've got two options, which are Neutron Star, which is an incredibly dense ball of neutrons. So it's collapsed together so hard that actually it's kicked out all of the protons and you've just got neutrons left. Or it could become a black hole, which is if it's really, really, really massive. So this is the most mass will become a black hole. Now, in the description, I've put a link to my Life Cycle of Stars video, which was a video I made 3 years ago. It's one of the first videos I made, and it was the first really popular video that I made. So go ahead and check that out. And what I'm going to do next is I'm going to talk about particle physics briefly. So think about that photo that I just shown you on my wall, which was this really high energy particle colliding with this target. Well, I want to talk about the principles of detection, and this is an A-level physics idea. And in my description to this video, I've put the descriptions. I put the playlist for my particle physics playlist, so you can go ahead and have a look at that for the extra details. But basically, that is a photograph of a particle interaction, and we detect what happens when particles collide using these principles, these four principles. The first principle is ionization. We can only make tracks of charged particles, so we can't really see individual particles. What we can do is we can see a kind of trail of where it's ionized things in space. So that actually is a kind of bubble tracks in some vapor, and as the particles, the charged particles, have moved through that, they've done ionization, so they've changed the atomic structure of the things they're going past, and that's left some little bubbles. So you have to infer that neutral particles are there by some of the other principles. We use Fleming's left-hand rule, so that's something you need to know from your GCSE. Remember, force, field and current, F, B and I people like. This direction of the force, this is field from north to south, this is current from positive to negative. To actually work out the charge on the particles. And we work that out because if the particles, we pass them through a magnetic field, then they move in circles. So if you think about that photo, they had these rings of these charged particles all moving around in circles, so it's what you call centripetal motion. So the force is at right angles to the motion of the particles. The particle itself is the charge, is the current in Fleming's left-hand rule, and the magnetic field is normally going up or down in the photograph in the bubble chamber. And so there's a force at right angles to that, which makes it accelerate into circles. So there's this centripetal force, and I want you, whenever you recognize something is moving in a circle, I want you to get that word centripetal force, or force towards the center of a circle in. Okay, so we can work out the direction of the charge, because if it is a different type of charge, then it will be going in a different direction. The field will stay the same. The force will be in the opposite direction. So depending if something is moving this way or this way, the force is here or here, tells us which direction, which charge they have, because the field is either into or out of the page. So that's an application of Fleming's left-hand rule, which you need to know in your GCSE, and you need to be able to be really good at using it in A-level. Okay, and then the last one, also scintillation. Scintillation is the idea of depositing energy. So we can infer a particle has been there because we can see its energy as it scintillates, as it kind of just decays on a charged plate. Okay, so it makes a little spark, and we can measure the size of that spark if you like. And then lastly, momentum. Now, depending on the radius of the curvature, so if we have two particles, both of which have the same charge, but one is curved more than the other, well, we can tell this one has a greater momentum than this one. Does that make sense? Because, well, okay, it's the mass and velocity, it's product of mass and velocity, which makes it more difficult to change its direction. So you can look at the different radius of the curvature, and hence you can work out the momentum or the mass or the velocity of those particles. I'll maybe just really quickly go back to the webcam shot and show you those two pictures again, so that you kind of put that into context. So this is my pillars of creation there on the wall there, and the particle physics, the particle tracks there on the wall as well. So you've got that. I think it's just amazing. This is one of my favourite photos ever. If you want a bit of time to get yourself motivated, go ahead and go to Hubble's site and have a look at the stuff out there. It's absolutely incredible. This is a photo from the Hubble Space Telescope, which is orbiting the Earth. It's absolutely incredible, and this is an amazing photo of I think it's a oxygen nucleus decaying into all of the different subatomic particles, which you learn about, and it's kind of like, oh, how many times we're going to talk about charge on a proton, neutron, electron? How many times we're going to talk about the mass of them? Okay, but there's a reason why you need to be absolutely sure about them if you want to go ahead and study physics in the future. Okay, yes, I'm just going to have a quick look at a couple of points here, and it's this one. It's really great. Thanks a lot. Nice to see perspective of life. It's hanging very well. Thank you very much. It's holiday time, but my first thought is let's get you guys motivated, get you guys revising. Rachel, I'm glad you can hear me absolutely fine. I'm not going to mark somebody's exam paper. I've just got some blank ones. Well, I'm going to actually drop this feed very shortly, and I'm going to come back with some GCSE for the WWE plug, some GCSE exam papers, and I'm going to go through those in detail. They are OCR gateway ones, but you know, I think that it's going to be enough coverage that it's going to be relevant to everybody AQA involved as well. I will do some AQA things in a live feed later on as well. So I'm thinking that's going to be about sort of 2:30 maybe. So go ahead, have a little chill now, maybe check out some of those videos in description, and have a little break for yourself now, but then come back, and 2:30 I will go through the first one of these papers, and then I'll drop again and come back half an hour after that, and you can ask any questions then as well. If you're A-level, then do go ahead and check out the links in description as well. There's loads of suggestions for you, loads of suggestions for you for videos that can really fill this time with really well. Loads of live feeds from my exam period last year as well that you can look at. And yeah, I'll be back with some things, and you can ask me the questions then. Nick, I will get your question in just a second as well. I'm just checking that I've covered everything that I kind of meant to. I hope it all looks okay and all kind of sounds okay. Let me know if you've got any suggestions at all. Start with the hardest. This is what I wanted to talk about just briefly. Start now with your hardest topic and work through to the topic that you like the most. It's really great that you're, on YouTube searching for things. Start now. You're obviously committed. You've done the right thing to start your revision on day one rather than take your break on day one. You want to look forward to your break, and this holiday is not your holiday. Okay, this holiday is the time to make progress and think about those GCSE or A-levels. Look forward to summer. I am honestly incredibly jealous of you all. You're going to have an amazing summer, whether it's GCSE year or A-level year. Really look forward to that. But look forward to getting there knowing you've done your best. Okay, yes, take a bit of a break to avoid your burnout, because you're about to embark on the exam period. It's going to start pretty much straight away as soon as you get back. Okay, but look forward to this summer when you're going to have about 10 weeks off. It's going to be absolutely amazing. Okay, and you're going to really enjoy it. And get there knowing you've done your best. Get there knowing you've done your best, so you don't spend the whole first kind of half of the summer up until exams, results day, thinking, oh, I'm really worried. Get there knowing that you've done your best and you've given it your best shot, and whatever you get, you can be really proud of. All right, that's my chat. Nick, no worries to interrupt me. Good question. A few questions that contradict by asking both percentage uncertainty and referring for measurement or reading. I'm not sure what you're asking there, mate. Percentage uncertainty and referring for measurement or reading. I think the best thing for you is, Nick, is if you actually send me like a picture. You can just take a photo of the question that you're looking at on your phone and email it to me, kit@gorillaphysics.com, and that would be really useful, and I can put that into one of the live feeds. I'm not sure how you mean. Oh, if they're maybe they're asking for the percentage uncertainty and referring to the measurement or reading. Sorry, bud, not sure exactly what you're asking me there. It does sound like a bit of a contradiction if they're asking for both of those. Can you do reflection, virtual, real, and inverted? Yes, I can. I do have a really good optics video WWE plug, so I suggest what you do is actually just Google Gorilla Physics optics right now, and I take you through those diagrams. I think really good video, one of my better videos from early on, right? And then ask it later on as well. But yeah, I certainly will do that if you like. Please take the time now just to like this video, and I will see you later on, 2:30. Let's, you know, put a little date in your diary, put a little reminder or something. I will be back and I'll whiz through one of those papers and I'll take any questions. So that'll be GCSE. If you're A level, then check out the suggested videos in the description as well, and I will see you all later on. All right, thanks very much.